Hello, this is a problem that I sort of made by myself. I mean, I used other people's works to come up with this problem. Okay, what are the solutions for positive integers x and y in the equation x squared y squared minus 3y squared plus 3x squared plus 1 equals 25? So in equations like this, we first try and factor this. Now, the method I use to factor two variables is shown in the AMC time prep video. Basically what you do is I have x squared here and y squared here. So when multiplied together, I have x squared y squared. And then I need to multiply it to get this coefficient. So I have minus 3, so it would be minus 3x squared. And then to get that one, I have minus 3, so I get minus 3y squared. And then the last one, I multiply those two together and I get 9. Okay, so that means that, here, let me rewrite this. X squared y squared minus 3x squared minus 3y squared plus 9 can be factored into x squared minus 3, y squared minus 3. Now it's important to notice that these are interchangeable. If I find all the values for x, I'll find all the values for y. Okay, and so basically what I need to do is I need to change this equation right over here to get it to this equation right over here so that I can factor it, because that's ultimately how I'm going to solve an equation like this. So to do that, the only thing missing is I need to add 8 to both sides. So once I add 8 to there, I get the plus 9, and when I add 8 to 25, that would be 33. Okay, so now I have x squared minus 3, y squared minus 3 is equal to 33. Now here I can break up 33 into 1 and 33, or to 3 and 11. Those are the only factors it has. Now problems like these are also a little easier when it's a prime number that you're dealing with, but this is also fine. So I just need to evaluate for this one, for all the possible values that work for this. If x is 1, if x can be 33, x is 3 and 11, because then I'll be able to find like what x is for 33 and x is for 1. Those will be the same for y. So all I'm going to do now is I'm going to say x squared minus 3 is equal to 1. Means that x squared equals 4 and x equals 2. Now, it's not going to be negative 2 because it's positive integers x and y. So that is one solution, which also means that y has the opportunity to also be 2. And that only works when the 33 also works. So I went in advance and I made sure that this works, because actually I'm not sure if this always works though. That's a good thing to check, but I did make it so that this does work. So we could have x be, so when y is 2, x be 6, or when y is 6, x could be 2. Now, I'm just going to match those up so that you can easily see those. Now for the next one, 3 and 11, y squared minus 3 equals 3, or sorry, x squared equals 6. Oh, that is not a square. And if you look back carefully on the problem, you'll see positive integers. So that does not work. And immediately we could also cross off 11 because both of them have to work for it to be a solution. But just for the heck of it, we can go through with it. X squared minus 3 equals 11. And you'll quickly be able to see that both of them don't work, because that is also not a square. So anyways, if you were to write out the solutions, you would write like for all x and y, blah, 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 you would have 2, 6, comma, 6, 2. And you can plug this back in to show that this works, and I really hope it does. Thank you for watching. Goodbye.